polygons, in particular, interior angles of polygons. Here's a question. What is the sum of the interior angles of a polygon? What is the sum of the interior angles of a polygon? And you're saying, okay, well, I know one polygon, the triangle, and the triangle sum theorem gives me this fact, that the sum of the measures of the interior angles of a triangle equal 180 degrees. Not a problem. I can do that. Good. But what about four-sided? What about five-sided? What about six-sided? What are the sum of the measures of those interior angles? What if we can divide each of these figures into triangles and then add up the measures of those triangles? Then we would get the sum of all the angles on the inside. What if we can take a look at this four-sided figure, divide that into triangles, in this case, two triangles, add up those triangle measures, and then we would get 360 degrees, no? Sorry. We would get 360 degrees, all right? So I took a diagonal. I went to a vertex, I drew a diagonal, and I found two triangles within a four-sided figure. Okay, this has four sides, and I came up with two triangles. This is three sides, and I came up with one triangle. All right, that should be triangle. We're looking for a pattern, that's why I'm writing this thing. Okay, and up here, this is a five-sided figure. And so how many triangles are we going to find inside of our five-sided figure? I'm going to go to a vertex, I'm going to draw a diagonal, I'm going to stay at that same vertex, and I'm going to draw another diagonal. And those are the only diagonals I can draw. I'm going to put 180 degrees for each triangle. That's 3 times 180, and 3 times 180 is 540. 540 degrees. Okay, so the sum of the measures of a five-sided polygon, the interior angles, is 540 degrees. So how many triangles are in there? That's 3 triangles. Okay, we've got something going here. When I have 5 sides, I've got 3 triangles. When I have 4 sides, I have 2 triangles. And when I have 3 sides, I have 1 triangle. And now we're going to have a 6-sided figure. We're going to go to one of the vertices. We're going to draw a diagonal. We're going to draw another diagonal. And the last diagonal right there. And I see 4 triangles in there. 4 triangles. So that's 184 times. And 184 times is going to get us 720. 720 degrees. And I can put in those 180s for visual effect there, there, and there. But what we really want to know is there a pattern? Is there a pattern? Look at the difference between the number of sides and the number of triangles. Can you see the difference here is 2? Number of sides and number of triangles, the difference is 2. Number of sides, number of triangles, the difference is 2. Number of sides, number of triangles, the difference is 2. The number of sides minus 2 gets us the number of triangles inside of these polygons. We take that number of triangles and we multiply it times 180 each time, and we end up getting the sum of the measures of the interior angles. That is pretty cool. Let's try it out one more time. How about this 7-sided figure right here? Well, if it has 7 sides, how many triangles should be in here? 7 minus 2, that should be 5 triangles. If it has 5 triangles, that's 5 times 180. That should be 900 degrees total. Don't believe me? Take a 7-sided figure, divide it into triangles, and you should find 5. So here is our magic theorem right here. I'm going to delete that bad writing. I'm going to put it into much better writing so you can see it clearly and give you a written statement for something that you can write down. N minus 2 times 180. This is the sum of the measures of the interior angles of any convex polygon. And the kids are coming, so this video is coming to an end. Hey, there's a corollary to this for regular convex polygons that you're going to see in the next video.